All right. Any questions? Any questions? Yeah, yeah, let's do it. It's Thursday. Mm, 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 mm.
You seem to be very happy tonight.
Maybe because I'm eating sugar. And it's Thursday night. My Friday.
True.
So I made this snack mix from leftover snacks in my pantry. And it's got M&Ms, chickpeas, dried cranberries, sriracha almonds. I think that's it.
That is a interesting combination.
It's pretty good. The chickpeas are a little bland, but that's why everything else
Yeah, the
comes
chickpeas
in.
and the sriracha almonds, like
Hey man, my pantry is full of snacks, and I was like, well, I'm stuck up here for a while, and I get hungry, so guess I'll pass the time for dinner. And the M&Ms, that's just a plus.
those are always good.
Mm-hmm. Peanut M&Ms or the pretzel M&Ms. Oh, those are good. The coffee ones weren't bad that they came out with.
I tried those.
The caramel ones are, it's like pure sugar, man.
But it's so good.
No, it wasn't good. Because they're not crunchy or anything. It's just like you're just biting in the caramel.
Peanut one, yeah, peanut butter ones were the best.
Oh yeah, those are good. Okay. Well, any questions before we start, y'all? I'll post these notes while I wait. Recap. Partial fraction decomposition. Boom. Here we go. Okay, if there's no questions, then let's do this because everybody else is probably like, yeah, he's right. Let's get this Thursday over with.
When's our first test going to be?
If we're doing partial fractions today, that is a good question.
I think I saw like the test was supposed to be on Tuesday. So I'm thinking like, are we not going to have any time to like
any time to review?
Like yeah, in between.
If I can spare the time, let me see. Boom. And that would push that there. And then that would push that there. Oh yeah, we have all the time in the world. So we can push the test till, because Tuesday's the 9th, right?
Yes.
Yeah.
Yes.
So we can push exam 1 till next Thursday.
And then we don't come into class Thursday.
Exactly. On exam days, you don't come to class. You just take the test and that's it. But it means Tuesday, we'll make it a review day. So come if you have questions and all that.
Those are awesome.
All right. Hey, it's good. Yeah. I was like, we are on partial fractions, and after partial fractions is our first exam. So yeah. Okay. Follow the schedule. Okay. So today is partial fraction decomposition. What's up? What? Oh, no. Okay. So what we're going to be doing today is taking a fraction and breaking it into multiple pieces. So we are going to decompose a fraction into pieces. That's what partial fraction decomposition is all about. Okay. And with that being said, there are 4 cases, oh my goodness, to partial fraction decomposition. And the first case deals with a rational expression that has a denominator of non-repeated linear factors. So that is the first one you see here as p over x minus a to the 1 over x minus a to the 2, all the way to the last factor of x minus a to the n. So we will decompose this fraction into multiple fractions as a over x minus a to the 1 plus b over x minus a to the 2, all the way till we get to that final fraction. So what I mean by that, what's going to be a good example? Wow, come on, laptop. Don't fail me today. I think my laptop's going to blow up soon. It gets really hot now. Okay. So to give an example of this, let's just say I had 5 over x plus 1 times x minus 2. Well, this is a rational expression that has a denominator of non-repeated linear factors. So x plus 1 is a linear factor and x minus 2 is a linear factor. So by case 1, if we wanted to break this fraction up into multiple fractions, or if we wanted to decompose it, by following case 1, we would rewrite this as a over x plus 1 plus b over x minus 2. And then from here, we would solve for a and b. But I'm just showing you how you would decompose such a rational expression. All good? It's an ugly 5.
So we would be solving for 2 variables?
Depends how many we have in the denominator.
Okay.
If there were 3 in there, if there were 4 in there, we would keep going down the alphabet.
Okay.
Okay. Case 2 deals with a rational expression that has repeated linear factors, meaning that you have factors that have the power of 2 or greater. So we have the expression here, p over x minus a to the n. And the way you would break this down is you would keep breaking the fraction down until you get to that final power of n. So a over x minus a plus b over x minus a squared plus ... all of z over x minus a to the n, where n is that final power. So again, a good example of that. I'll just keep using 5. Why not? Let's say I had 5 over x plus 1 cubed. And I guess the way to keep this simple is the power tells you how many fractions you have. And the way you would decompose this is you would write a over x plus 1 to the first plus b over x plus 1 to the second plus c over x plus 1 to that final power of 3. All right. You see how that works out?
So is A, the uppercase A, B, and C, do those actually stand for a number, or we're actually just gonna use
Exactly.
those?
That's why I said once we decompose them, we're going to solve for A, B, and C, which represent a number. For now, I'm just showing you how to decompose fractions based on these rules. All good?
Roger.
For now, right? Okay. So case 1 and case 2 deal with linear factors. Case 1 deals with non-repeated factors. Case 2 deals with repeated linear factors. And now case 3 will deal with a rational function whose denominator is a non-repeated irreducible quadratic factor. Ugh. Which means you are given a denominator that cannot be factored at all. So to represent that, again, I'll just use 5. And if I'm given some unfactorable denominator such as this, you will decompose the form into ax plus b over that denominator. So this would become ax plus b over x squared plus x plus 1. That's what we would do. And then solve for a and b. All right, so that's case 3. And case 4, of course, deals with a irreducible repeated quadratic factor. So case 3 and 4 are very similar. So if you are given an irreducible repeated quadratic factor, such as p over ax squared plus bx plus c to the n, you will expand it until you get to that nth power. So I can just use the example from above. If I said 5 over x squared plus x plus 1 to the second, I'm just going to keep it simple, to the second. This is an irreducible repeated quadratic factor. I would then expand this to ax plus b over x squared plus x plus 1 plus cx plus d over the final power x squared plus x plus 1 squared. And of course, you would keep going based on the power. Remember, if you have a repeated factor for either case, that tells you how many fractions you should have. So since this was 2, This means I'm going to have two fractions. Okay.
I have
And
a quick question.
go ahead. Go ahead.
Would there ever be like a half? Or
What do you
would
mean
they
a
all be
half?
whole numbers? Like if it's x squared plus x plus 1.
Oh,
etc.
like say that's to the one half.
Yeah. Or like it's
Then-
a fraction.
Then we cry and we figure
Oh,
something out.
okay, for sure. I was just wondering.
Sounds good.
Don't worry. You only get whole numbers here. I think if it was a fraction, none of these cases would be for it because n has to be an actual whole number for it to work.
Thank God.
But I'm sure it could work. Partial fractions are, you'll see them come back in Cal 2. They make Calculus 2, they make integrals a lot easier to calculate. And then if you keep going further, I think the only actual job that will use partial fractions later on is the electrical engineer. So it helps them break down their problems in real life.
I'm changing my major.
So for now, we just get to deal with the algebra. Okay, so these are how the 4 cases work. And yes, you can have multiple cases. You can use case 1 with case 3. You can use case 2 with case 4. You can use case 1 with case 4 and everything else. You can even use all 4 cases on a partial fraction. So these cases can be mixed together. As long as you know how to break them down by the case, then we can go on ahead and solve. So let's
How do you
get
use them
started.
together?
What's that?
How do you use them together? Like how that?
Good question. It all depends on what the denominator gives us. So in my denominator, I could have a linear factor that's not repeated. I could have a linear factor that is repeated. And I could also have an irreducible quadratic factor. It just depends on the problem. Just know that you can use cases together. It's not just going to be like, oh, this is a case 1, perfect, let's move on. These are case 2s. No, it could be, oh, this is a case 1, 2, and 3. Or this is a case 1, 2, 3, and 4. So all 4 cases can be used on a single problem. Math God help us. Ha! Good. This is more of algebra God today. This is nothing but algebra. So today, partial fractions are about clearing fractions. They're about solving for variables. And if it gets hairy, they're about systems of equations. You guys remember substitution and elimination method? That's all coming back today. I do have some tricks, but we'll get there later. Okay. So let's start with the let's start with the fraction of x over x squared minus 5x plus 6. So the first thing you want to do before attempting partial fraction decomposition is factor your fraction if it's possible. So x over x squared minus 5x plus 6. How far can I zoom in here? Right there, that's perfect. Okay, so step A, factor your denominator. Does x squared minus 5x plus 6 factor?
Yes.
Yes, to what?
X minus 3, x minus 2.
X minus 3, x minus 2. Good. And now, step A is done. We move on to step B. And step B is about figuring out what case to use. So step B, all we have to do here is analyze the denominator. And look at our denominator. Are these linear factors?
Yes.
Are any of them repeated?
No.
No.
No, these are different linear factors. So we have case 1 because case 1 deals with a denominator who has non-repeated linear factors. So this is case 1. And I'll just put these here, x minus 3 and x minus 2. These are non-repeated linear factors. I always feel like, what was it? Was it Toy Story 2 or 3 when he gets trapped in the toy store and the guy's like, NRFB, never removed from box.
I think it's
You guys-
2.
You guys know what I'm talking about, 2. All right, good. This is a non-repeated linear factor, which means if you know the case, we move on to step C and we decompose using case 1. So step C, I start off with the factored rational expression, and I break it down by case 1. Case 1 says I'm going to get a over x minus 3 plus b over x minus 2. There's our breakdown. We have just decomposed it. And then we move on to step D, and we start solving for A and B. Everybody good so far?
Yes.
Yeah.
Okay. So now, step D, it's called clear the fractions. So look at this equation. So our job is to get rid of all the fractions. And I say one thing to keep it really simple. If you're ever going to get rid of your fractions, if you want to get rid of your denominator, multiply everything by your common denominator. So for this equation, what is our common denominator?
X minus 3 by x minus 2.
Very good. So we're going to multiply this whole thing by that common denominator. So I'm going to have x minus 3 times x minus 2 times, and on the inside, x over x minus 3 times x minus 2, close that, equal to the same thing, x minus 3 times x minus 2 times everything on the right side, a over x minus 3 plus b over x minus 2. So step D is where we clear fractions. And if you're ever stuck and you're like, I don't know what my common denominator is, guess what? It's always here on the left side. Cheat codes. Look at that. Everything's where you need it to be. Okay. And now you are going to distribute this to everything. So what's going to happen on my left side?
You're just going to end up with x.
You're just going to end up with x. Good. What's going to happen on my right side? What am I going to be left with?
It's going to be a times x minus 2.
Good.
And then b times x minus 3.
Very good.
So it's basically almost like multiplied the opposite denominator.
Exactly. So if you want to see what's going on, when you do x minus 3 times x minus 2 times a over x minus 3, your x minus 3s will what?
Cancel.
Cancel. And that's what's going on here.
Almost like you're cross multiplying, but I don't want to say that because
Yeah,
like
don't say that. It's called cross canceling. Cross multiplying is different. It's called cross canceling when you are canceling fractions. Okay. And now we're here. Any questions before moving on?
So on the left side for this case 1, remember, is it always like on the left side? Are you always going to end up with just a single whole number?
Depends on what's in your numerator.
You're going to be left
Okay.
with your numerator, right?
Yeah,
Just
you're going to be left with whatever your numerator
Or
is.
never numerators. Okay, that's
Yep.
yeah.
Okay. Okay. So now our job is to solve for A and B. So what we're going to do now is distribute A and distribute B. What step am I on? I am D, clear fractions, and then E, equate coefficients. So we're almost there. So this is still step D. So the left side remains X. And I'll get AX minus 2A plus BX minus 3B. Okay. So before we start learning what equate the coefficients are, I want you to put the light terms together on the right side. So that means I'm just going to rewrite this as ax plus bx, and then minus 2a minus 3b. Okay. And then what we're going to do next is factor an x out from these two terms. And this is going to help us do a process called equating coefficients, okay? So I'll have x equals x times a plus b minus 2a minus 3b. So now this is going to finish step D. All right. So now let's get into step E, where we equate coefficients. All right. So before I continue, I'm going to show you what that means. Let's say if I had on the left side of my equation, let's say I had 2x squared plus 3x plus 4. And on the right side of my equation, I had ax squared plus bx plus c. Well, what equating coefficients does, it's kind of just like it sounds, is you are setting the coefficients of the like terms equal to each other. So what I mean by that is if I have 2x squared here and ax squared there, then if I equate those coefficients, 2 is going to equal a. That's all the equating coefficient process is. So let's try it again. If I have 3x here and bx here, what is b going to be equal to?
3.
3. And then if I have 4 here and c there, what is c going to be equal to?
4.
That's it. This is how you equate coefficients. All right. All good? We're going to try it out now. So, equating coefficients, let me rewrite this. X equal to x times a plus b minus 2a minus 3b. Okay. So, if I equate these coefficients, I have x here and x here. All right. Well, what are the coefficients of these x's?
1.
1. So with that being said, if I equate these coefficients, 1 is going to equal a plus b. You guys see that?
Because it'd be 1 multiplied by a plus b.
Good.
Because
So
x is equal to
if I rewrote this one as a plus b times x, now what's my coefficient of that x?
a plus b.
A plus b.
Okay.
See it? Guess it makes sense if I write it that way. Here. And we equate these coefficients. So I guess, here, let me do this. Oops, not that. So there's a 1 in front here. So we would equate those coefficients. There we go. That's better. And 1 would equal a plus b. And now, all that's left here is this 2a minus 3b. Well, when we are dealing with partial fraction decomposition, these numbers are considered constants, which means they will only be equivalent to a constant on the left side. Well, do you see a constant on the left side of this equation?
No.
No.
Negative.
And what number represents nothing?
0.
0.
So if you don't see a constant on the left side, and remember a constant is a number without a variable, then you will set the constants on the right side equal to 0. Now, you're probably wondering, like, well, what if a number was there? Then good. What if this was x plus 5 equal to negative 2a minus 3b? Then, in that case, negative 2 minus 3b would be set equal to what number?
5.
5.
5. Catching on, catching on?
But isn't the point to like find A by itself or B by itself?
And that's what we're doing right after this. Because after you equate coefficients, we now solve for A and B. And now this is why I say, I hope you remember how to solve a system of equation. Because, what is that? Is that step F? Let me see. F, solve the systems of equations. Because look at that. We have equated coefficients. And now F, we have a system of equations. And when I say that, well, you have, and I'm going to rewrite it this way. A plus B equal to 1, and negative 2a minus 3b equal to 0. You guys remember how to solve a system?
Yeah, I could just
Sorta.
multiply the top equation by 2.
Good. So remember, if you solve a system of equations, you can do it two ways. You can do it by substitution, or you can do it by elimination. Elimination is a lot faster. And remember, with the elimination method, you pick a variable you want to get rid of. And in this case, Ethan's picking A because, well, 1, this is negative and this is positive. And 2 is smaller than 3. So all we're going to do is multiply this whole thing by 2. And if you do that, you get a new equation of 2a plus 2b equal to 1 over negative 2a minus 3b equal to 0. Whoops, what did I mess up there? That should be a 2. And now we'll add these equations together, and what variable is going to cancel?
The A's.
A. And I'll be left with 2b minus 3b, which gives me negative
A to B.
negative
Equals
b equal to 2, and therefore b equals what?
Negative 2.
Negative 2. Yeehaw. Now all we have to do is solve for
A.
A. And you can choose whichever equation you want to plug it into. Which one looks easier?
A plus B equals 1.
A plus B equals 1. So you have A plus B equals 1, and B is negative 2. So A plus negative 2 equals 1. A minus 2 equals 1, and A equals
3.
3. Woo, man. Look at that. And oh yeah, we're almost done. Our final answer, G, is just rewriting the breakdown. So we're just going to put A and B back in for our final answer. You're going to get 3 over x minus 3 plus negative 2 over x minus 2. And there's our answer. Oh my goodness. Any questions on that?
That took like 30 minutes.
It sure did. Told you we had a lot to get
We have
through.
like 4 more cases. Oof.
You know it. Don't worry. It gets faster after this because this is algebra and you guys know it.
So would you say, like, this is a little bit side tangent, but would it be better to always kind of just prioritize elimination over substitution, since we're going to be using elimination in like linear algebra and stuff in the future?
Yeah. So, I mean, elimination is always the way to go, but sometimes towards the end, these get a little crazy. So substitution might be your best friend when it gets to that. Your brain's going to be like, oh, there's an A, there's a B, there's a C, there's a D. I don't know what to put together. It'll be just fine. Okay. But yes, elimination is the way to go. You could have solved this by substitution as well. But if you want to get these done a lot faster, there is a faster way. And it's fun. It's called, and we'll start here on this step. Today, guys, I welcome you to the X Games. And like I said, we're starting off where we left off right here. Like, I always wanted to go to the X Games. Yeah. And what's great about the X Games is you get to choose a value of X that will eliminate A or B. So you pick one. So you're going to choose a value for X. You eliminate A to solve for B. And then after that, you'll choose a value of X to get rid of B to help you solve for A. So this is how X Games work. Let's look at A times X minus 2. What value could I let X be to make this expression come 0?
2.
2. All right, get ready for the fun, guys. I say let X equal 2. Now this means you plug 2 in for every single X you see, even on the left side. So if X equals 2, I get 2 equals A times 2 minus 2 plus B times 2 minus 3. And then you get 2 equals A times 0 plus B times negative 1. And oh my goodness, you get 2 equals negative B. And guess what? B equals negative 2, just like we found 30 minutes ago. Which means we now do the same for A. I ask you, what number could you let X be to make this part of the expression become 0?
3.
3.
Let X equal 3. You'll get 3 equals A times 3 minus 2 plus B times 3 minus 3. And you'll get 3 equals A times 1 and 3 equals A. Holy moly. Was that faster?
That was like 10 times easier.
You just pick values of X.
Does this only really work for non-repeated linear?
No, it works for all of them.
Okay.
It just depends on the type of partial fraction you're given. So now, if you like the long way, stick with the long way. If you like the X Games, let's go X Games. So if you're solving these, pick one. Don't try to do both at the same time. Choose one and stick with it. Okay, let's move on. How many I got? 1, 2, 3. Oh, not bad. 3 more. Okay. So let's do it again. Yay! All right. So we start off with this one, and it says factor the denominator. So here's step A. X plus 2 over x cubed minus 2x squared plus x. What can I factor out?
X.
An x. That'll leave me with x squared minus 2x plus 1. Can I factor this more?
Yes.
Yeah, it'd be go ahead.
X minus 1 squared.
There you go. Yeehaw. Look how good that was. And now B is recognizing the case. Well, let's look at our first term, x. Is that a repeated or non-repeated factor?
Non-repeated.
Non-repeated.
Which means it's a case.
Case 1.
1. And let's look at x minus 1 squared. Is that a repeated factor?
Yes.
That's a case
2.
2.
2. I'm going to catch a case. That's right. There you go. Now you know what cases to use. So now you'll know the breakdown. So we get straight to the decomposition. C. Oh, there you go. C. Decompose. And we start with the factored left side of x plus 2 over x times x minus 1 squared. And I start by using case 1. Case 1 is just going to put a over that linear factor of x. That's it. This part was case 1. And then we go on with case 2. I'm going to put b over x minus 1 plus c over what?
X minus 1 squared.
X minus 1 squared. That's it. That's the decomposition.
So we're done. Yay.
Far from it.
Oh.
You have now decomposed it, which means you now get to clear all your fractions. So now we're on step D, clear. What will we multiply both sides by?
X times x minus 1 squared.
X times x minus 1 squared times all this lovely stuff. Oops.
So because the x minus 1 in the middle right there is a repeated factor, so you don't need to do that. It's just the x and the x minus 1 squared.
Yep. All right, guys, we're in the clear stage. So now you distribute everything. And the left side will always clear to the numerator of x plus 2. The right side, all right, y'all. What am I going to have?
I got a times x minus 1 squared, right?
Good. Plus?
Plus b times x minus 1.
Good. Plus?
C times
cx.
That's it.
Okay.
Woo! We cleared all the fractions. Now, here's where you make a choice. Do you guys want to go the long way or do you want to play X games?
Let's go the long way.
Oh.
No, I'm joking.
Who let him answer?
Don't look at me.
I'm just looking at, I don't know who I'm looking at. As far as I know, you're the only two in class that answer.
That
All right.
participation grade, though.
You know it. All right. E. Now we're on the E because now we're going to call E X games. Burn it. So I'm going to do
That's a great answer.
I'm going to do that to her grade. All right. So let's say we want to get rid of this one. What would you let x be?
I would make it equal
1.
to 1.
Good. So we're going to say, where can I write this at? I'll do it here. And you plug 1 in for every single x. So I'll get 1 plus 2 equal to a times 1 minus 1 squared plus b times 1 minus 1 plus c times 1. 1, 1, 1, 1, 1, 1, 1. And you'll get 3 equal to a times 0 squared plus b times 0 plus c, which means c equals what number?
C equals 3.
Good.
So is it always going to end up with canceling all the terms except for the last one?
Or it just depends on what number you pick for x.
It could have completely different ones.
So now, since we have c, we need to figure out how to solve for a or b. So now let's look at this one. What could you let x be to make this thing become 0?
1 as well.
Well, if you make that 1, that means this becomes 0 as well. And we're left back here. So you never want to choose the same number again.
Okay.
So looking at bx times x minus 1, what number could you plug in for this x to make it 0?
Zero.
0. Good. You would let x equal 0 and plug that in. 0 plus 2, and I'm just going to save some time here because if you plug in 0, cx becomes 0, and all of that becomes 0. So all you're left with is a times 0 minus 1 squared, which gives you 2 equal to a times negative 1 squared, which means 2 equals a. Not bad.
Wait. Why is not a not equal 1? We're trying to divide by the 2. Oh, never mind. Nope. Never mind.
Yeah.
I was letting you figure it out. Okay. Well, we have A and C. All we need to do is find
B.
And here's the greatest part about the X games. In order to find B, you can let X be any number you want except the first two you have chosen.
What about just plugging them in and
plugging in A and B? I mean, A and C? We'll do that, but we still need to solve for B because you still, even if you plug in A and C right now, you still need to plug a number in for X.
Okay.
So that's what I'm saying about the X games. The last number is any number you want to choose except for the first two. So keep it small. What's a good number you want to go with?
Let's try 3.
Let's go with 3. All right. He says 3. Let X equal 3.
By first two, you meant the 1 and then the 0 we plugged in?
Exactly. We
Okay.
never want to choose the same numbers again. There we go. And I'll get 5 equal to a times 2 squared plus 3b times 2 plus 3c. And then I'll get 5 equals 4a plus 6b plus 3c. But do we know the values of a and c already?
Yeah.
Yes, sir.
Plug them in. A is 2, So that becomes 8 plus 6b plus c is 3. So this becomes 9.
Too big.
Yeah, you went way too big, man. And
Dang
then
it.
you'll get
So it'd be
5
-2.
equal to 6b plus 17. And I'll just keep writing over all this. Move that 12 over. Move that 12 over. Move the 17 over. And you'll get -12 equals 6b. And -2 equals b.
Haha.
Yeehaw. Next time, choose like 2 or -1, okay?
All right.
I did say you can choose whatever you want.
So this was the long way or the X way game way?
This was X Games. This actually would have been shorter than going the other way. Oh, yeah. And then we're almost done. We can move straight to step G. Since we skipped step F, we didn't end up with a system of equations. So we end up on step G, which is our final answer. 2 over x plus -2 over x minus 1 plus 3 over x minus 1 squared. There you go.
On the long way around, did we ever solve for B?
Will we, wait, if we distribute everything, will we solve for B?
Oh, because
Well,
we
you plug in the values you have for A and C, and you're left with one variable. So you kind of like just use algebra to get B, even though the numbers were like big, they still brought up the answer that you were looking for.
So they answered for you?
yeah, I'm just gonna rewatch this later. Yeah.
There you go. I was like, what do you mean did we find B? We found B right there.
Well, I meant like on the long way, because there's a long way, then the X game way. But
Yeah, if you did the long way, we would still be solving for A, B, and C, no matter what. Which I'll show how to do if we have time left. I just want to get through these problems.
I didn't realize that was the E up there was the X Games for some reason. I thought this was a long way the whole time. That's okay.
Oh my goodness. All right. You eat some M&Ms, man.
I'm not a night person.
I'm night and morning. Yeah. All right. So next, 3x minus 5 over x cubed minus 1. Let's go ahead and factor this. Anybody remember how to factor a difference of cubes?
It's gonna be like
no,
you go ahead, bro. I was gonna say, isn't like x minus 1, and it's time like x
-1 times x.
It's gonna be an x like plus 2 something in the middle.
Plus 2 or plus 1x plus 2x.
Just one.
Oh, just one.
That's it. There you go.
And it's always the opposite sign on the second one.
Exactly. Woo. Okay. Can you factor this more? Are there any factors of 1 that can make 1?
No.
No. So this is done. This is factored. All right. And for those who you need a refresher, remember that a cubed minus b cubed factors to a minus b times a squared plus, what was it, ab plus b squared. There you go. Okay. So now we move on to step B, and we look at our cases. Let's look at the first term, x minus 1. Is that linear?
Yes, sir.
Yes.
Is it repeated or non-repeated?
Non-repeated.
So we have a case
1.
1. And then let's look at the next one. We can't factor it, which means this is an irreducible quadratic. So is this a repeated or non-repeated irreducible quadratic?
Non-repeated.
Which is a case
3.
3. We have our cases, which means let's move on. And
case 2 is repeated quadratic, and case 3 is non-repeated.
Case 2 is a repeated linear factor. Case 3 is a non-repeated quadratic, and case 4 is a repeated quadratic. How do I remember all this? It's the decompose. All right. So we start off with our factored fraction. And we decompose. We start with case 1. A over x minus 1 plus. Now we go with case 3. Bx plus c over x squared plus x plus 1. There you go. There's your decomposition. And now we clear the fractions. We good?
Yeah.
For now. And again, now we clear fractions, so we just multiply everything by that, right? Distribute, distribute, distribute. There we go, y'all. And remember, whenever you have the two terms, so when we distribute with this fraction, you must remember to put bx plus c, those two terms, whatever they are, you must remember to put them in a set of parentheses. If you don't, you're going to mess it up and it's going to be awful because we are already doing a lot of work. Oh, excuse me. Okay. Now let's play X games and let's look at this. What value should we let X be to get rid of that?
1.
Good. And if we let X be 1, this whole thing becomes 0. So this means we have A. One plus one plus one. Okay. So let A be 1. It helps us solve for A. And then let's go ahead and solve for C, because looking at this, if you want to get rid of B, what value could you let X be?
0.
0.
0. I should move that down below. And -5 times 3 is -15. -15 plus 2, -13 over 3. And 13 over 3 equals C. Okay. We have A.
What a lovely number.
We have C. And now we find B by choosing any number you want for X, except for 0 and 1.
2.
2. All
I'm
right,
not letting
let's
him choose
go
a big
2.
one again.
Yeah, don't pull a me.
Hey, man, you could choose 2, 200, 2,000, no matter what. You're still going to get the
say
same
100.
answer. You'll still get the same answer.
Yeah, let's say we did and really don't.
Guys are no fun. Okay. Four plus 2, 6, 7. Right, 13/3. Yep, yep, yep. Negative 14/3 plus 13/3. Negative 1/3 plus
So it'd
2b.
be 2/3.
Add that over. And 1 times 3 is 3. 3 plus 1. 4/3 equals 2b. And then divide by 2, and yes, you'd get 2/3 equals b. Ooh,
Okay.
man. Fraction work. Look at that. Which means step G, we have our answer. Negative, oops, too big. Negative 2/3 over x minus 1 plus 2/3 x plus 13/3 over x squared plus x plus 1. Look how beautiful that is. My goodness. Well, I hope you like fractions.
And so we can just leave it like that, like a fraction over fraction.
Why not? I mean,
Not saying here's my math, I will take it.
you could rewrite it like this. Which does look prettier. Oh, I'm adding extra now on the test. Just yours though, Jessica.
Yeah, I mean, they're always fine. I'm just curious if my math lab's gonna freak out or something on that.
I think we'd take the first one. If not, that's why you're like, well, I have the answer, but I input it wrong. I could be like, okay, I can fix that. Except for Jessica's. Okay, let's do it. Last one, guys. Okay, last one. X cubed plus x squared over x squared plus 4 squared. All right. Can we factor this denominator?
No.
No. Why not?
Because that would give us an imaginary number.
Oh, it works. Or it's a sum of squares, right?
Or that.
Yeah, both of them are good. Good reasonings. You cannot factor a sum of squares, which means we move on. B, we go to the case. This is a quadratic irreducible factor. Is it repeated?
Yes.
Yes. That means we have a case. Four. which means we go straight to the decomposition. And I have x cubed plus x squared over x squared plus 4 squared. And by case 4, this becomes ax plus b over x squared plus 4 squared. Not squared, sorry. Just x squared plus 4. Plus cx plus d over x squared plus 4 squared. And then d. Clear. Multiply this whole thing by that denominator.
For another way, instead of like saying multiply by the least common multiple or whatever it was like this, could we always just multiply it by the denominator on the left side, pretty much?
Yeah, because that's the common denominator. That's what I said. Don't try to twist my words and make them yours.
Yeah, I'm good. I don't think I want to do that.
Plagiarism.
What?
This is math. We don't know how to read.
Yeah, we sure don't. Oh, this snack makes it dangerous. All right. Nope, that's just cx plus d, right? Okay, so we're here, but unfortunately, this time X Games isn't going to work out.
Oh,
So yes, we can get rid of A and C by letting X be 0, but that wouldn't get rid of B or D. And the only number that can make this part 0 is what type of number? What was that? I heard mumble.
imaginary.
Yeah, imaginary. If you guys wanted to explore that, we could, but we're not. Yes, you can plug in an imaginary number and it would definitely work. But we're not going to do that. We're going to go back to the old school way just because we haven't been there in a while. So what we're going to do here is distribute everything, or basically FOIL these two. And go back to lovely equating coefficients. AX cubed plus 4AX plus BX squared plus 4B plus CX plus D. AX cubed, 4AX, BX squared, 4B. Don't want to miss anything. And now combine your like terms on the right side. And there's only one x cubed. And there's only one x squared. But then I have a 4ax. And I have a cx. And all that's left is a 4b plus d. So what we're going to do next is from this term, we're just going to factor out an x. That's it. And then we should be able to equate. And I'm going to rewrite it as this. 4a plus c times x. Okay, which means we have a step E again. Equate.
So why would we not just take an x squared out of the a and the b?
Because that means you would have x squared times ax plus b, which means we would have a leftover x in here. And if we're equating coefficients, that's not going to work out for us.
Okay.
That's a good question. Because now if we equate, I have an ax cubed over here and an x cubed over there. I should be writing purple. Which means if I have x cubed equal to ax cubed, what does a equal?
1.
1. A, that's nice. And then if I have an x squared and a bx squared, what does b equal?
1 as well.
1. A, that's nice. And then if I have 4a plus cx, do you see an x on the left side?
No, so it would be equal to 0.
That's right.
And then the same goes for 4b plus d.
That is correct. But let's keep with this one first, because do we know the value of a?
One.
This means c is
-5.
negative.
I mean -4.
And then just like we said, the constants 4b plus d, you don't see a constant on the left side. So that's equal to 0. And do we know what b is? This means d is also
-4.
There we go. We got it, y'all. Don't have a step F because there was no system to solve, which means we go straight to G. And our answer is 1x plus 1 over x squared plus 4 plus cx, so -4x plus d, -4 over x squared plus 4 squared. Done and done.
So can you clarify me so there's not a system to solve?
Because remember how the last system we did was we did elimination method?
Yeah.
So there was no elimination method, right?
Instead, we substituted this time, right?
I guess you could say, yeah, we substituted, but there wasn't really a substitution method or anything like that, other than plugging in what A and B were.
Okay.
I mean, if you want to consider that a system of equations, you can, but it's not really. So if you really want to label that step F, go ahead, Ethan. Okay.
I don't really care. I'm just trying to solve this.
Okay, guys. And that's partial fraction decomposition. Oh, yeah. One thing I didn't put in these notes that's on your homework is what is a proper rational function? Or just, I won't say function, I'll just say expression. So to be a proper rational expression, the degree of the numerator must be smaller than the degree of the denominator. So a proper rational expression would be something such as x over x squared plus 1, or we can even say x squared over x cubed plus 1, or we can even say x plus 1 over x squared plus x plus 4, as long as the degree in the numerator is smaller than the degree in the denominator.
Kind of like that horrible rule from asymptotes.
Kind of, but not the same, right? And also, if it's not a proper rational expression, such as, I'll just say not proper, and let's say we have x squared minus 1 over x plus 2. Let me rewrite that. I don't like ugly stuff. X squared minus 1 over x plus 2. If it's not proper, you have to put it into proper form by a lovely method called
My favorite.
long division. So if you come across an improper rational expression, you must fix it by long division, which means I would put x plus 2 into x squared minus 1 and solve it or simplify it. So that's what you have to do. So that's what I didn't show in these notes, but I guess now I did. Okay.
Are we gonna do that on the homework? Like, is there gonna
Yeah.
be a problem?
It's like the first 2 or 3 questions on the homework. It's going to ask you, is this a proper rational expression? Is this a proper rational expression? And if it's not, you're going to have to use long division to fix it into a proper rational expression. Yeah.
Great. 'Cause I forgot how to do long division.
Oh, good time to bring those memories back. Whip out that 1414 notebook, huh? Or just access my 1414 notes over long division. Okay. Other than that, we are done. We have 20 minutes left. So if you needed me to show the long way on the past 2 problems, let me know. Or if you got questions over the homework or anything, also let me know. And if you are all good, then have a good weekend. We're done.